This is Dr. Ramu, Professor Head of Computer Science Engineering, Narsimha Engineering College, Hyderabad. In last class, we have seen the data model. In today's class, we are going to learn levels of abstraction in the DBMS. And abstraction. In last class, we have seen that what is the abstraction. Abstraction means hiding something, right? I'm going to give a simple example. You just take that an example of the bike, right? As a user, you know, right? When you press the brake, it is going to stop, right? You know up to now, but you don't know the process how it is going to stop the bike, right? How it is going to stop the wheel, right? How the functionality is going to happen. It is not required for you, right? Who will take care of the entire process? The mechanic will take care of the process, right? How it is going to work. As a user, you no need to know the things, right? How it is going to work. The same thing you are going to apply here also, right? You are going to separate the things from the complex system to the right and the user perspective. These two things are going to separate. When you're going to separate the external user, right? End user, no need to worry about the right behind the system. And even you consider the ATM machine, you know that when you insert a card and you enter the pin, then you will get the money or you will get the your account details, right? You doesn't know how it is going to work, right? What will happen when you insert a card, and how it is going to process your card, and how you are going to, right, when you enter a pin, how it is going to evaluate, and how it is going to check your balance. All the things you no need to know, right? Because you are an end user. For an end user, no need to know all the things, right? The only who will take care of all the things, the developer. The developer side, he is going to take care of the things. The same thing you are going to apply here also, abstraction, right? So you just keep it these examples in your mind. We will discuss the same examples in this video, right? I'm sorry. Abstraction, the process of hiding the irrelevant details, right? As a user, right, user no need to know the things about the how the brake is going to process and how your ATM card is going to process, right? As a user, it doesn't know. As a customer, say for example, I'm a HDFC customer, I no need to know the how the ATM card is going to work when I insert into the ATM machine, right? There is an end user. Provides a simplified view of while ensuring the data security and independency. It is going to provide the security and independence to the as a customer, right? That is the purpose of abstraction. Abstraction means it is going to hide the irrelevant things from the system. And why it is important, right? Simplifies the user interaction. As a user, right, if you want to know all the things, then no one is going to use the ATM machine. Got it? And enhance the data security and reusability, right? When you do the abstraction in the database system, right, it is going to enhance the data security and the usability, right? I am going to explain in the further slides how it is going to work. The purpose of the data abstraction, complexity of the data systems, right, hides the complexity of the data system and presents the relevant data to the user while keeping the internal details hidden. What it is going to do, it is going to give the data what you require, but no need to know the internal things. That is going to assured by the data abstraction, right? And achieves the data independency, right? For example, if you have a 3 levels over there, right? For example, if you choose something in this level, right, it is going to not affecting the top level and the bottom level. That is going to assured by the data abstraction. Data achieves the data independency, right? And the levels of abstraction, there is a 3 levels of abstraction in the database. The first one is the physical level and logical level and the view level, right? When you observe the diagram here, the databases are there, right? The databases, right, this is the user. There is no need to know the what is going to happen in the database. Even he no need to know. For example, listen, so I am the ATM, right? I am the HDFC customer, right? I no need to know the how the my currency, right, my amount is stored in the databases and which format it's stored, right? And is a dollars format or the Indian rupees format or the UK dollar format. So we no need to know all the things, right? So we need to know only how to insert a card into the ATM machine, right? How to get the money from the ATM machine. Only those things need to know, right? The remaining things no need to know. The same thing here also, right? And the logical level and the physical level. We'll see one by one level, right? First one is the physical level. Physical level is that the how the data is going to stored in the devices, right? The indexing level and the structure and everything. See the definition. They describe the physical storage structure of the databases, right? How the physical structure of the database and the uses the physical schema to define the storage details. Got it? And the characteristics. When you come to the characteristics, so it's the lowest level of abstraction. It's the lowest level of abstraction and describes how data is stored in the blocks and records. Blocks and records. How the data is stored in the blocks and records and the facts. Handles are storage details like a data present on the disk, right? For example, if you consider your hard disk, right? How your hard disk is going to hard disk, the data is going to stored, right? The sectors, right? And the tracks. You just observe that, you just go through this is a separate concept, right? How the data is stored in your hard disk, right? And that keeps the actual representative of the entire database in your hard disk, right? The example, data stored in the binary files and the indexed files. Data stored in the binary files and the indexed files. This is the example of the physical. Next, we will take the logical or the conceptual level. When you consider the logical or the conceptual level, right, describes the overall structure of the database. Overall structure of the database focuses on what data is stored and relationships between the data, right? Characteristics. So it's a middle level of the abstraction. Middle level of the abstraction uses a conceptual schema, defines the database entities, attributes, and the relationships. Got it? So it is going to give a clear design, and the facts hides the internal details such as a physical storage. Right here, the people who are going to handle the conceptual level no need to worry about the physical level. They are going to concentrate on only on the conceptual and designing of the databases. No need to worry about the physical databases, and that ensure the data consistency and the security, because we design our database like this. Got it? And the used by database administrators and the developers. Who will handle this conceptual level? Database administrators and the developers. Examples. Schema defines a student ID, right? How the student table is going to stored in the schema, a relational database model, right? Is attributes are the ID, name, and the codes. These are going to stored in the database schema. Got it? And the view on the external level, like user perspective, right? As a HDFC customer or ICICI Bank customer, right? Or the bike user, you can take any user is comes under the right view. This is provides a customized view of the database for a different users, right? Hides the unrelated details, right? It is going to hide the unrelated details. Characteristics, high level of abstraction. It provides a high level of abstraction, and each view is defined in the external schema, right? And the facts allows the user to access the only relevant data and the end user interaction with this level. Got it? And then knows the view of the schema. Example, a librarian view the book ID, title, and the authors, right? And it comes as the borrower. Borrower is not going to see the author. He is going to see the ID, title, and the availability, right? For the everywhere, we are going to match with the one unique ID. That is called as a primary key of a table. We learn all the things in the future. Primary key. Sorry. And the data independence. For the data independence only, we are going to design this abstraction, right? The data able to change the schema at one level without affecting the others, right? If you change the data in one level, right, one schema, it is not going to affect the others level. That is the reason we are going to adapt the abstraction. Got it? in the abstraction, physical independence, right? The changes in the storage details do not affect the logical schema. Example of modifying the indexing methods. If you change the indexing methods in the physical level, it is not going to affect the conceptual schema. And as well as if you change the logical independence, right, the changes in the logical schema do not affect the external level, right? If you change something here, right, the user perspective, it is not going to change. Adding a new attributes in the table, right, it is not going to affect the user level. Got it? And coming to the comparison of all this abstraction, right, this is a physical level and low level, right, conceptual, and the view level, the focus, the storage details, here the structure and relations, and the user specific views, right? For example, I require to see the only user, name, roll number, and the CGPA. Then it is going to retrieve the data accordingly, right? It is going to do the schema, right? It's a physical schema and the conceptual schema and the external schema, and the users, administrators, designers, and the end users. Got it? And the example, binary data and indexing, here tables, relationships, right? Customized reports, right? Whatever you require, this is going to display according to the end user requirements. Got it? This is what about the data abstraction. In the next class, in the advantages of the data abstraction. In the advantages of the data abstraction, it is going to simplify the data interaction for the users. Got it? Like what we discussed in the initially starting of this video, right? The bike user no need to know about the internal things and achieves the data independence, right? And ensures the security by hiding the irrelevant details and allow the role specific access and the views. Role specific, right? For example, in a bank, there is a manager is there, right? And cashier is there, right? And the clerk is there. These are the three different users. For the three different users, they are going to see that three different types of data, right? The manager can do anything, right? Cashier can update only cash related details, and the clerk is not going to touch about two levels, right? The clerk is going to only do the some kind of modifications in the bank. Got it? Bank users data. This kind of the level of the role of the based on the role, we are going to give the specific access. Got it? And today's we see the data abstraction. Next class we are going to see the different the purpose of data independence and the structure of DBMS very clearly. Okay, thank you.